What's going on, everybody? Thanks for tuning back in. Before we start this part, there's a couple file changes that I made before this tutorial in order to help get us going. So the very first thing I did was I added the stateowner.name to our state file, and that's because once we have a bunch of NPCs running around changing states, we're going to want to keep track of them when we're logging so we don't lose them between the NPCs and the player. Secondly, I took the enums file and I split it between all of the different sections that I had inside of it because I want to keep my enums clean, and I want to group them because a lot of these groups are going to have a lot of enums. And then finally, inside my globals file, I got rid of the export for the grid size and I just turned it into a const because this actually isn't going to change. We want 16 to be constant at all times. So now when we're using it inside of other files, instead of doing a globals instance grid size, you just do globals.grid size, and that takes care of that. We'll leave this as an export because we might want to play around with the seed when we're taking care of the game, but for now, we're just going to go with this. In this video and the next one, we're going to take a look at adding some NPCs to our game. So to continue with the world building, what we're doing is we're going to add NPCs with different movement types, and we're going to get them going around the map and talking to us and adding some more life to our level. Pretty much the last thing that we have to do before we start working on things like sound, UI, adding the actual Pokemon to the game, etc. If you like what you see, go ahead and like and subscribe. And if you're feeling really generous, you can support the channel by buying a coffee. Okay guys, let's get into it. So I think the first thing we want to do is create our NPC scene. It's going to be very similar to our player scene that we already created. If you want to open your player scene, you could take a look at all the things you have here. It's pretty much going to have all the same components minus the camera 2D. So I think that would be a good place to start. So let's create a 2D scene. And instead of node, we're going to switch this type and we're going to make this I believe it's character body 2D. And then obviously it's going to cry about the collider. We'll fix that. I'm going to name this class NPC. We're going to add a child node, add our collision shape 2D. And to keep it the same as the player, we're going to keep the name the same as well. So this is called collider in the player as well. We can go ahead and add a new rectangle shape 2D. And similar to the player and everything else we've been adding, what we're going to do is we're going to take this collider and we're going to make the transform scale 0.9. That way we don't have any random collisions when we're trying to walk next to something. I'm going to save this scene in my scenes characters folder next to the player. Next, I'm going to add two nodes, and the first one I'm going to call input, and the second one we're going to call movement, and we're going to create the scripts for everything in a minute. Next comes our animated sprite 2D, and it doesn't have sprite frames on it right now, but we can go ahead and add those in a second. Next, we're going to add a node and call it state machine, and then we're going to add two states underneath. One is going to be called roam and one is going to be called message. Similar to the player already has these two. So what we can do now is we can go through and create all of our scripts. Some of them are going to be reused from the player, some of them are going to be brand new. And for the animated sprite 2D, I'm just going to throw some new sprite frames on here for now, but we'll come back and worry about that in a minute. First, for our NPC, we're going to go ahead and attach a script here, and that's going to go inside of our scripts folder. And I'm going to add it to our favorites here. We're going to go gameplay, characters. I'm going to favorite this so I keep coming back. And this is just going to be called NPC. So that's created. And we'll add our namespace game.gameplay. I'm going to copy that. And then I'm going to go back to Godot and keep creating my classes. Next on my input, I'm going to attach a script, and inside the characters, I'm going to call this NPC input. You can see we already have the player input, so we're going to make the NPC input. Now if we go back, the movement script is going to be the same that we actually used in our player, and that's the script called character movement. So if I go to characters and just add character movement, I can load that here. Next, I'll go to my state machine and do the same thing. That's hiding in scripts, utilities, state machine. And then we're going to create two new scripts, our NPC roam state and our NPC message state. So go ahead and do that now. So you can see the player message state and the player roam state. I'm just going to rename this to NPC. And finally, create one here for my NPC message state. And add my namespace here. Okay, that was a lot, but we got through it. Go ahead and rebuild just to make sure everything's okay. So the next thing we have to do is create our sprite frames that our NPC is going to be made from. I've already added my PNG files or my sprite maps to my assets here underneath my characters folder. You can see I've added a couple. I've added this bug catcher, this gardener, and this worker. These are going to be available for you in the repo, and I've given full credit to the author inside of the README, but these are the ones I'm going with. You can use any characters that you want, but just keep in mind that when you do the sprite frames, it's good that these sprite sheets, the players or the characters are all the same size so that you can interchange them. Much like we did with the sign, how we could switch between metal and wood, I think it would be cool if we could switch between the different types of NPCs that we're going to have. So the three that I'm going to add to the game here, the bug catcher, the gardener, and the worker, I think that updating the sprite in real time is going to be useful, especially for debugging. So what we have to do is basically, if you go back to your player and you look at your animated sprite 2D, you can see we have our 12 different animations here. Our idles, our turns, and our walking, and it's in our 4 cardinal directions, down, up, left, and right. What we're going to do is we're going to go ahead and we're going to create a new folder in our resources called sprite frames. And we're going to create 3 sprite frames, one for each of the assets that I just showed you. And we're going to add all of the idles, the turns, and the walks so that they can be interchangeable with each other and with the player. I'm going to show you how to do the first one, and then we'll fast forward, assuming that you create them all yourself. So right click and create a new resource. And then the resource is called sprite frames. And it's going to ask you to give it a name. I'm going to start with my worker. And then I know that I'm going to want I think that's one too many. I think I'm going to want 12 of these, and then I'm going to start naming them. So I'm going to do idle up. And you can see that I have all of these named. Awesome. So I'm going to just create the first one. And then much like we did, you can go back to the other video and see how we created them, or just look at your player to see how you put all the sprite frames in. But I'm just going to add my first one here. So I'm going to go to my resources, or sorry, I'm going to go to my assets, my characters, and I'll do my, I think it was worker that I'm doing first. And my idle down is just this. So I add the frame here and I hit save. And then just so I can position this correctly, I'll make my sprite, my default sprite frames on my animated sprite 2D here. I'm gonna do a quick load and I'll do the worker here. Oops. And then I'll go to idle down, and then you can see that the size pops up. So this will help me actually get the size that I want, which is right here, just popping off the top a little bit, just like our player. I'm gonna save that. And then I'm gonna add all my animations and then create 2 new sprite frames for my other 2 characters. And then we're gonna keep working after that. So let's go ahead and do that. Okay, now I got all 3 of my sprite frames. Now I think it's time to actually edit the NPC class. And as we go through the class, we will fix all of the subclasses along the way that we need to take care of. So much like we did with the sign, we're going to add the tool decorator to this so that certain parts of this can be run inside of the editor, specifically when we want to update the appearance. Now, since all of our components are pretty much static, I'm going to just go ahead and declare them private for now and then load them all in the ready function, depending whether or not we're in the editor. So the first thing we're going to need is going to be an enum, and that's going to be our NPC appearance. So what we should do is create a new file inside of our enums folder for our NPC classes. So here we're going to do our namespace, and we're going to do game.core. And the first thing we're going to work on is our appearance. So we're going to do an public enum NPC appearance. And right now, that is either the worker, gardener, or bug catcher. So we'll do bug catcher, gardener, or our worker. And then we have to figure out the NPC movement type when we take a look at its configuration. So we're going to look at 4 different movement types when it comes to NPCs. We're going to look at static, where they don't move and they're always facing the same direction, wander, patrol, or look around. And I think that's all we need just to keep things relatively simple, even though it's going to get complex when we start programming it out. So we'll do a public enum NPC movement type. And we'll do static, wander, patrol, and look around. And those are the 2 enums we need for now. So here we'll do a private NPC appearance, and I'll just use lowercase for now. And we'll give that a default value of worker. And then we'll export the public facing one and then have it update the appearance when we need it to. So we can get those out of the way now. So right here we can do an export, and we'll actually do an export category, and I'll just call this traits because we will add more to this later down the road. And we're going to do a public NPC appearance, and we're going to have the getter function just return the private variable, but the setter function will check to see if our value has changed. And if it has, what we're going to do is we're going to assign that value, and then we're going to call update appearance. And we haven't created that function yet, so we could just do a private void update appearance and just leave that as a placeholder for now. Okay, everything here looks good. So now let's go ahead and define some more of our components. So we're going to add our private animated sprite 2D, and we can just call that our animated sprite 2D. We're going to do our private NPC input, and I'm going to keep everything lowercase when it's a private variable just to stay the same. Then we'll do our private state machine, and then finally our character movement. Now, if I do have to access one of these later in the future, I'll change it to public, but I'm just leaving it private for now because only the NPC class is worried about it at this moment. Now, the next thing we're going to do is we're going to create a dictionary similar to the way we did in our science class. So if you go back to the science class, I believe we put that in our levels, you will see this, this dictionary here with these resources. We're going to do something similar. We're going to do a private read only. We're going to do a dictionary, and I want that from Godot. We're going to do our NPC appearance, and then sprite frames as our value. And we could just call this our appearance frames. And this is equal to new, and then we could just define everything we need to here. So we're going to do our NPC appearance dot bug catcher, and then gd dot load, and the resource we're loading is our sprite frames. And then all we got to do is give it a link, and you can do that off memory, or you can go to the editor and you can copy the resource right here from the path. So if I paste that here, we're good to go. And then I'm going to add that 2 more times, and then just change it to my gardener and my worker. Sweet. Okay, the next thing we're going to do is we're going to actually create a new tool that's a global class, and that's going to be our NPC config. And it's going to be specifically our input config. So the way that the NPC behaves, so what we defined before, the static, the look around, the patrol, that kind of thing, is going to be a configuration object that we can assign directly to our NPC input file. But because we can't see any of the variables here from this in the inspector, we're going to use a configuration file that we just pass down to make things pretty simple. And you'll see what I mean once we define it. So let's create a new class inside of our characters, and we're going to call this our NPC input config. And this is going to be defined by firstly adding our namespace. And this is going to be a global class and a tool so that we can create it as a resource and do a public partial class NPC input config. And this is going to inherit resource. Now, this is where we're going to define all of our variables. So let's do that now. I'm going to split this up into an export group and just call it movement. And then I'm going to add subgroups. So I'm going to do a subgroup here, and I'm going to call this common. And the very first thing we're going to have is our NPC movement type. And our default is going to be static. Next, we're going to, oh, I forgot to export that. Next, we're going to export a public array, not from system, from Godot. And we're going to do strings. And this is going to be our messages, so that when we interact with this NPC, these are the messages it's going to play back for us. So next, for our wander mode, what we need is a public vector2. I believe it's our wander origin. This is like our starting point when we start wandering around, and we'll do our vector2.0. And the reason that we have that is because we have a radius that we don't want to get too far from. So next, let's copy and paste that and do a public double. We'll do a wander radius, and that can be a default of 64. Next, we can do a public double wander move interval. So we'll do wander move interval. And this is basically the time between each step. So it's going to move and then pause for this amount of time. So we'll say 2, and then it will take its next move. So let's copy this. And for our patrol, what we want is we want an array of vector2s. And we're going to call these our patrol points. And then we're just going to have a patrol point interval, or call it our patrol move interval, just to keep everything the same. And then finally, we can have a patrol move index, or patrol index if you want. And this will be keeping track of where we are in our patrol array. And this will default to 0. And then finally, for our look around, we're just going to have an interval. Yeah, just call it our look around move interval. Or you know what, just look around interval, because we're not actually moving. So these are all of the different settings that we can change, that we're going to want to change anytime we instantiate an NPC into our levels. And if you need more variables than this, or you're doing a different move type, this config file is where you're going to put it. So now what we want to do is we want to go to our NPC input. And we're going to change this to inherit our character input class. And all we're going to do here is we're going to export public NPC input config, and we're going to call it config. And we're going to actually have one inside of our NPC class as well. And that will be responsible for assigning this config directly. So let's go back to our NPC. we're going to export our public NPC input config to our NPC input config. And I think that's all we need for our variables, and we can start writing the actual code. Let's go ahead and start applying some of our settings. So we're going to override our ready function. And there's a lot we have to do in here because since this is a tool, it's going to run inside of the editor, but I don't necessarily want to load everything. I only care about updating the appearance when we're in the editor. So what you can do is you can do if our engine.isEditorHint is set to true, so we are in the editor, we're going to just update our appearance, which we'll create in the end here, and just return. So we don't have to do anything else. So this is inside the editor. Everything else below here is runtime setup. So we'll do our NPC input is equal to, and we'll do a get node, and we'll do NPC input. And this is just from our input. And oh man, I can't believe I did that backwards. And then here we do our NPC input dot our config is equal to our NPC input config. Next, we can do our state machine. And you can go ahead and do this for all of your nodes. We're going to change our state to roam because we want to start in the roaming state. The animated sprite 2D, same thing. And then finally our character movement. So this will make sure that everything is working in place here. Now let's go ahead and create our update appearance and see if we can get it to work. So here I'm going to do a logger.info and just say changing appearance in editor. And we have to do the same thing we did in our sign class to check to see if everything's null. So we're going to do if our animated sprite 2D is equal to null. We're going to try and grab that. If it is null, we'll just error out and return. If our appearance frames, and we try to get the value, and what we do is our NPC appearance, and our out var will be our sprite frames, else our animated sprite 2D dot sprite frames will equal the sprite frames. If not, they will be equal to null. So let's go to the editor and see if we miss anything for this. So if I go to my NPC here and I rebuild and clear the console here, if I go to the NPC here and I switch this, it should switch to one of the other two sprite frames. So you can see changing appearance in editor, changing appearance in editor. Great, that works just fine. I'll just set it back to the default for a worker for now and save that. And if you also take a look, this NPC input config, if I create a new input config and expand it, you can see that underneath all these categories, I have all of those inputs that we put in. So this part is working properly as well. Okay, so now let's go through each of the components and make sure that everything is where it should be. For example, in the input, the config we don't have to worry about because we set that at runtime. But movement, we need our character and our character input. So our character is our NPC and our input is this. So we can save that. If we look at our movement, sorry, that's what we did look at. If we look at our animated sprite 2D, we actually need to attach the script for it. So let's go ahead and do that. We're going to attach our characters, and I believe it's the character animation. So we'll load that, and we'll just go back to Godot. And we need our character input and our character movement. We need all that hooked up. The state machine needs the customer, which is the NPC. The current state is set at runtime. And then these aren't states yet, so let's go to these and make these inherit state. And for our message state as well, we will input our state and then rebuild. And then for our roam state, we have our state owner and our state machine. It'd be much easier just to set these in code, but this is how we had it before, so this is what we'll do. And same thing for our state owner and our state machine here as well. And we'll save all that. Let's see what happens if we add an NPC to our town. So right now they don't do anything, they'll just stand there. However, let's just see if we interact with them as a collider, see if there's anything we have to change that way. So let's go ahead and add a node 2D to our level. I'm going to call this NPCs. Underneath it, I'm going to instantiate my child scene, and I will instantiate an NPC, and I will bring him right here. And as far as the config goes, I'm just going to right click and make this unique. And I'm just going to leave it like this and see what happens. So if I hit play and I walk up to him, you can see that I can't go through him. So you'll notice two bugs. For some reason, my project input is still not going to nearest, so I'll change that in a second. But you can see right here, I actually appear in front of him, and he should appear over me with the top part of his sprite. So we'll fix that. This side works, but because I'm the player, I think it takes precedence if they have the same Z index. I can't remember. This is no problem. We can fix this. So let's take care of both these issues. We're going to first go to project settings, and in textures, I believe it is, the default texture is that it? Is it nearest? I can never remember. Let me go to our player. And look at the texture. Yeah, it's nearest. I don't know why it's not doing that. So let's go to our NPC, animate sprite 2D, texture. I guess it just didn't change. So let's save that and take a look at him now. There, he looks much better. And in order to fix the Z index, what we have to do is go to our NPC, and we have to override the process function. So let's do that. Inside of the process function, we're going to check a few things. First thing we're going to do, we're going to check to see if the engine editor hint is true. So if this is happening inside of the editor, I'm just going to return because I don't want to really do anything in this function here. So if we aren't in the editor, basically what I do is I want to get my var player is equal to the game manager.getPlayer. It's a function we created before. And all I want to do is I want to check to see that if the player is not equal to null, I want to make sure our Z index is either higher or lower than the player's, depending on the position. So all we care about is the Y index. So we're going to set our Z index of our NPC equal to, and what we'll do is we'll do our player dot, we'll do our player dot position dot Y. If that is less or equal to our position dot Y, we want our Z index to be higher because the Y-axis increments as it goes down. And if not, we want to do 4 to be underneath the player. The player's Z index is 5. That was the first thing we did. So if I save that, and we go back to the game, rebuild, and hit play, when we go above, we should appear underneath. That works. And when we go below, we should appear in front. Perfect. So the last thing we're going to do for our NPC class itself, before we dive into all the subclasses, is add our play message function. So our sign class has a play message function when we're next to it and we hit the spacebar or the use key and it plays a message for us. So we're going to do the same thing for our NPC. So at the bottom, we're going to create a new function. It's going to be a public void play message. We're actually going to pass something in here, and that's going to be a vector2 direction. So this is the direction that the player is facing when it interacts. So first, let's add our engine check. So engine.isEditorHint. Just in case this runs here, I don't want it to. Get rid of it. Next, we want to check our character movement. If we are moving, we're going to go ahead and return because I don't want to interact with somebody that's moving and mess up their grid snap. So once we have movement in with our NPCs, if we interact with it, don't even bother playing this function. Next, what we want to do is we want to check to see if our NPC input dot direction is not equal to the player direction multiplied by -1. So if our direction that we're facing isn't the opposite of the player direction to make it look like we're having a conversation, we're going to change that. So we're going to take our NPC input, which is a character input inherited class, and do our direction is equal to the direction passed in multiplied by -1. And then we're going to do an NPC input dot emit signal. And that signal is going to be a character input signal dot signal name dot turn. Next, we're going to call the state machine, and we're going to change the state to message. So we're not using the global signal for this. I only want one NPC, and that's the one we're talking to be in the message state. All the other NPCs can move around and do what they got to do. Finally, we could do the message manager dot play text. And the text we're going to play is our NPC input config dot messages. Now, the way we were getting rid of our messages before was we were just closing the UI and then changing it manually. We're going to go back through and change the way the message manager works really fast just to make sure that everything works the way it should. But before we do that, let's just see what the behavior is like right now and see if we have to change it. So let's go back to our small town and rebuild. And inside of our NPC input, let's add just a simple message here, just saying, hey, how's it going? And save that and hit play. If I go up to this NPC right now and hit spacebar, nothing happens. And that's because we haven't added the actual message to our state yet. So let's go back and do that. And how we're going to do that is in our NPC roam state, in our player roam state. If we scroll back down and go to our get use input function, basically we're checking the colliders. So we have a case for the sign, but we don't have a case for the NPC. So all we have to do is add one for our NPC. And then we have to pass in the player direction. And we have the character movement and the player input already imported at the top. So all we have to do is do our player input dot direction. And if we save that, go back to Godot, rebuild. And I hit space. Nothing happens still. Oh, there we go. Hey, how's it going? So there's a few things we have to change here. So you can see here that the player enters the message state and the roam state. But now when I walk away, you can see that nothing happened with the NPC, and that's because we have a little bit of work to do. So let's go through and fix everything we need to fix. So the first thing we're going to want to do is you'll notice that when we tried to talk originally, nothing happened, and that's because our direction and our target position aren't the same thing. We want to be always using the use key where we're looking, not where our last target position was. So in order to change this, what we need to do is we need to modify our getTargetColliders function. We're going to change this to be the input direction. So what we can do is we can do our player input dot direction. So this vector isn't the size of a grid. It's only one. It's only a unit distance of 1, where we need 16. So we'll do our input direction multiplied by our, basically by 16. So you do globals dot grid size. And then what we do is we take this and we add it to our current player's position. And how we get that is we do player state owner dot position. And that should give us the ability to talk as soon as we're looking at something. So if I rebuild, hit play, and walk up, I should be able to hit spacebar right away. Yeah, and that works. Okay, great. So a few more modifications to the messaging. So inside of our player message state, you'll see that we changed the state here. And I don't want to actually do this here. I want to take care of this in the actual state itself by using the signal. So what we're going to do is we're going to go to our player roam state, and we're going to copy this where we change the state to message if the value is equal to true for our message box open signal. And we're basically just going to invert it here. So if I go here, and if I import our signals, this time if I do the false version of that value, I want to change the state back to roam. And all I want to do here is scroll the text. And then inside my message manager, if I scroll down and I go to the part where it makes the message box go invisible, I'm going to emit a global signal here. So I'm going to take this, copy it, and go false. And now, like the player, I'm going to take that ready function for my player message state, and I'm just going to copy that and go to my NPC message state and do the exact same thing, where if the signal is received that the message box is closed and we're in the message state, go ahead and take us out of it. So let's go back, rebuild, and hit play. So if I walk up to my NPC here and I start talking, once I close this, you should see at the bottom that the NPC and the player both enter their roam states. So you can see NPC exiting message state and entering roam state, as well as the player. So our messaging states have been fixed, and now we can move on to actually adding the movement for the NPCs. And if you want to get even more clear, with that modification we made to the state before this video, if I change this to worker, and I hit save, and I hit play, you will see that worker is entering the roam state instead of just the NPC class. So if you have different names for everybody, then the logging will be very clear at what's going on. So now let's go ahead and get into actually implementing our wander and our look around movement types. So I'm going to close these tabs here because they're getting a little out of control. Let's go ahead and go to our states, and we're going to go to our NPC roam state. So we need a couple things here. So let's do an export category. We're going to throw in some state vars. Let's go ahead and export our public NPC input, and we need our character movement. So do our public character movement. And we're going to need one more variable for now anyways, and that's going to be a double, and that's just going to be our timer. And this timer is going to be the original amount of time that that the NPC is going to wait until it starts doing all its movements. So you could just do something like this. And then this variable is actually going to be reused with all of our timers. So it's going to help keep track of when it's time to make a new movement. We're going to go ahead and override our process. And before we fill that out, we're going to create 3 functions. Well, 2 functions for now, and then eventually our patrol. So we'll do a private void handle wander, and that's going to take 2 things, a delta and an interval. And then we're going to do another one called handle look around. That does the same thing. And then finally, we're going to create a new private function that returns two vectors. We're going to call it get new directions. And this is going to help us actually get our new direction and our new target position. So how we're going to do this, let's fill this function out first before we fill out anything else. So what this is going to do is we're going to have a vector2 directions, and this is just going to be an array of all possible directions. So we're going to do our vector2.up, vector2.down, and then vector2.left, and then .right. And then next we're going to do a vector2 chosen direction, and we're not going to declare that yet. And then we're going to make a loop with a tries variable. So let's create a do while loop. And the condition here will just basically be while tries is less than 10. And we're going to just basically be looking for a new direction. We're going to set our chosen direction equal to our directions. And then we're going to pass in a random integer. And we're going to get that from our random number generator in our globals. So we'll get our random number generator. We'll do a random integer range. And we'll do 0 to directions.length -1, or you could just put 3, but I'm just going to do it like this. And then we're going to declare our vector2 next position equal to our character movement dot character dot position plus the chosen direction multiplied by the grid size. Now, what we're going to do is we're going to check to see if our NPC input .config .movement type is equal to our wander, because this is the part we're interested in. We're going to check to see if the distance from our wander origin is far enough. If it's too far, basically what we're going to do is we're going to try again until we find a direction we're facing that leads us to a position that's within the wander radius. Otherwise, we're just going to go ahead and break because we don't care about the look around distance from the origin. So here you're going to do a float. We can just call it distance from origin, and that can be our next position dot distance to. And here we're going to do our NPC input dot config dot wander origin. And if the distance from origin is less than equal to the NPC input config, and I believe it's wander radius, then we can go ahead and break. Otherwise, we're going to go ahead and keep going through this loop until we find a direction that we can wander to. So again, if the movement type is wander, we have to check to see if we're far enough from the wander radius. If the movement type is anything else, aka the look around, go ahead and just take the first value that we found. After the loop, you can go ahead and return the chosen direction, and then the chosen direction multiplied by the grid size. So this will return the direction, and this will return the target position. So let's go up to our process and start filling stuff out. So the first thing we're going to say that if the character movement is moving, so if we're already moving, then we don't care about anything else. We're just going to skip until we're standing still. Next, we're going to switch on our NPC input config, and we're going to switch on our movement type. And for this video, we're just going to have two cases. And the first one is wander. And the second one is look around. For this, we're going to handle wander. You're going to pass in the delta, and then you're going to pass in the NPC input config, and I believe it's going to be the wander interval. We're going to do the same thing here, except we're going to handle our look around, and this will be our look around interval. Inside of our functions, we're going to do a timer minus, whoops, we're going to do a timer minus equal to the delta. And then if the timer is greater than 0, so basically we're still in our interval, just return for now. Then we're going to grab two variables, and that's our direction and our target position. That's going to be equal to get new directions. And we're going to make our NPC input direction equal to our direction. And then we're going to do the same thing with our target position. And these variables are all shared by the character movement. So just filling them in here will automatically trigger all of the movement and everything that we need once we send our signal. And we do that with our NPC input emit signal. And then like we did before, it's going to be our character input, signal name, and then walk. We don't have to worry about turning because we're always going to be walking. We're never going to be holding still. And then at the end here, the timer is going to be equal to our interval, and this will reset our timer. Now we're going to do something similar for the look around. We're going to check to see if the timer is still going. So here we don't care. We could probably do this inside the process, but I'm just doing it here for now. And then we could copy this again. And then what we could do here is we could check to see that if our chosen direction, so if our direction is equal to our NPC input direction, you can go ahead and just reset it now because this doesn't really do anything. And then you can go ahead and just copy these, all three of these from here actually, or all four of these, sorry. And then the only difference is that we're going to emit the turn signal, and that's it. So I think that's everything we need. Let's go ahead and go test that out. So I'm going to rebuild. And I'm going to put this guy here, and I'm going to actually change this to the gardener because I want a gardener over here, and she's just going to have the movement type of look around. And then the other variables don't really matter except the look around interval. Let's change the look around interval to 3.5 and save that. And I'm going to hit play. And let's go see if she looks around every 3.5 seconds. And before we do that, you can already see that we've hit something wonderful in the debugger. So we clearly forgot to do something. And I forgot to set my, in my state. I forgot to set something. So let's go to, I'm just going to go to my NPC here. And in my roam state, I have to add the input and the movement. And then save that. And let's try again. And now it's not complaining anymore. So if I walk over here and look at her, let's see if she starts looking around. So you can see she's looking around. But you saw for a second there, when I'm holding down my movement keys, you can see that she's moving too. So it looks like we might have overlooked one thing. Let's go to our character movement script and see if there's any input being expected from the player. So if I go to character movement, this right here is probably what's happening. So inside of the update function, you can see that I'm checking to see that if we're not moving and we're not holding a button anymore to play the idle animation. So this right here, I don't want this to happen if we're the NPC. I only want this to happen if we're the player. What we can do is we can go ahead and get rid of this. And inside this, we can check to see if our getParent.name is equal to player. So this is how we're going to check that if we're the player or not. And then I can check to see if the module's action is pressed to just return. So basically if we're holding down the button, return. Otherwise, go ahead and emit the idle signal. So now if I go back and I hit play, and I walk up to our friend here, you can see that as soon as she moved and I'm walking around, nothing happened. So let's talk to her. And you can see that she turns around and says, hey, how's it going? And then she leaves the state once the message closes and starts moving around again. So that looks like it's working properly. Now let's add someone who's wandering. So inside this grass over here, maybe what I'll do is I'll take this grass. I'll select this guy, this guy, this guy, this guy, this guy. And I'm going to duplicate it and move it up because I'm going to add a little spot for my bug catcher here to go through. So NPCs, I'm going to instantiate an NPC. And let me just find them here. Sorry, this takes a second. And I'm going to put this guy right here. And I'm going to change this to bug catcher. And the NPC input config, I'm going to make this unique. And set the wander. And then the wander origin right now set to 0, 0. And we don't automatically set it, so I'm just going to change it to wherever the transform is. So that's 240 and 176. 240 and 176. Otherwise, he would just look around like the other guy. The wander radius, I'm going to set to, let's set that to 36. Just so it kind of stays in the grass over here in this area. And then I'll change the message to something like, hey, be quiet, I'm looking for bugs. Shh, be quiet. I'm looking for bug Pokemon. And save that. And then the wander interval, let's make this guy fidgety. Let's make this 0.5 and save that and hit play. Now, the wandering itself is going to work, but there's a couple of errors. Number one, he's going to be able to jump over this ledge like we are able to because we haven't programmed him not to. And that's going to cause some issues with the wandering. And also, you didn't see it here, but if I restart it, if I try and get in his way or go into the same square that he's moving towards, we might either cross or end up on each other. Yeah, you see he can walk right over me. So there's a couple things we still have to do to make sure that all of our movement isn't chaotic and no NPCs or players intersect with each other while they're moving. So what we have to do is basically, if we have this NPC here and I'm standing, let's say right here, and we both want to move to this square, whoever decides to move to the square first should reserve it. In that case, we're going to add just like a little reservation system to each level in order to prevent collisions like the one you saw. So that's the first change we have to make. And then the second change we have to make is scanning for different types of colliders and whether or not we're a player. So first, let's take care of the level. So inside of our level script, we're going to just add a private read-only. I believe it's hash set from C#. This isn't a Godot thing, but I don't really plan on looking at it. So if you want to use a Godot array or dictionary like that, you can, but this is just easy to scan. We're going to call it reserved tiles. And then we're going to have three functions. We're going to have a public bool called reserve tile. And that's going to take in a vector2 position. And then we're going to have a isTileFree, which will also be a bool. And then the final function will be a public void release tile. And this is going to allow us to free up that tile on the grid. So once we move to that position, we'll erase it from the grid because our collider is in the way now. But if we are just moving into it, then the release tile won't be called yet. So for the reserve tile, basically we're going to check to see if our reserve tiles contains this position. If it does, we're going to return false. Otherwise, we're going to add it and then return true. Nice and simple. isTileFree is simply going to return our reserve tiles contains position. So if this contains the position right here, so if it is in there, we just want to negate it and return false. And then release tile is simply going to be reserve tiles dot remove, and we'll do position. And that's why I like working with the hash set, because it's just a couple easy commands instead of scanning loops and stuff. So that looks good to me. So next thing we have to do is go back to our character movement, and we have to add a couple things. So when we're about to move, we check to see if we're already not moving and the target's not occupied. We also need to check if the scene manager dot get current level, and that returns the level that we're currently on. And then what we can do is check, I believe it's is tile free, and then we can pass in our target position. So basically it's saying if this is true, then we're good to go. If not, it's going to ignore this and not move. And then I'm going to copy that. And then all the way down here in our stop moving, we're going to free up that tile by taking this and doing a release tile. And then finally, inside of our movement script, if our thing isn't occupied, so we're able to go here, we're going to actually reserve the tile. Actually, we don't have to do that. We can just do the reserve tile here. Sorry, that works. So if the reserving the tile works, then the tile is reserved, and then we release at the bottom. Yeah, there we go. That makes sense. So the other thing we have to do is go to our target collision here, the is target occupied, and we have to account for a few different things. So we're going to rewrite this, and first we're going to check to see if the result.count is equal to 0, so there's no colliders. We just want to return false. If the result.count is equal to 1, there's only one collider, then we want to use this code right here. So instead of collision, we're going to do our result 0. And then finally, if there's 2 or more colliders, instead of scanning everything for a true and a false, we're just going to return false. Sorry, I mean, we're going to actually return true. Sorry, if there's 2 or more colliders, return true. Otherwise, we're going to keep running into each other. All right, let's build that and test it one more time. And now let's see if I can go to where this guy's standing. Yeah, we can't walk into each other. I'm desperately trying. And after he moves out of the way, the tile's free, and I can follow him. And I can still talk to him. And everything seems to be working. Okay, that seems to be working good. So our wander and our look around seem to be working pretty good. And all the interactions are working good. Everyone's changing their states like they should be. So I think that's all we're going to do for this video. In the next one, we're going to add a third way of moving, and that's patrol points. So for example, you have somebody standing here, and you have a waypoint here, here, or maybe they're just like walking around or something like that. We're going to use some built-in navigation functions in Godot and plot a path for them to walk where they don't hit any colliders and get the patrol movement nice and fleshed out. And then that will be the last type of movement we put in. And after that, I think it's time to start working on Pokemon. Okay, guys, thank you so much for tuning back in, and we'll see you in the next one.